Hi, Professor and TAs. I'm Tingyu Yang, and my partner Zhao Hongmai will present you our project. Our project is about object detection and recognition on Pascal dataset using faster RCNN. Our purpose is finding multiple objects in one image. Find object means detect where the object located in the image and what class this object belongs to. First, we're going to introduce how Faster RCN works. Faster RCN has 4 steps to do the job. First is processing through the convolutional layers, and second is introduce region proposal network. Third is processing through region of interest pooling, and fourth is detect and classify the object.
So just like the normal convolutional neural network, we use VGG16 network to get the feature map of the image, which has 13 convolutional layers plus 4 mask pooling layers. Here is some examples of feature maps of one image. So the top left one is our input image, and others are the significant feature map that we get from the convolutional neural network. Then we use this feature map to go into the region proposal network. We use all the point of the feature map and treat it as an anchor point and plug in 9 different ratio and scale bars onto it, as you can see. Then we use the train regional proposal network to classify all the bosses to see if this is a foreground or background. Then we apply non-maximal suppression to select 300 anchor bosses as region of interest.
After processing region proposal network, we will get 300 proposal boxes together with our feature map. We use them as input to region of interest pooling. During region of interest pooling, we separate each proposal box vertically and horizontally into 7 sections, and we do max pooling on each section. Then we will have a 7 times 7 times 512 representation for one region of interest. So we will have a fixed size for all purpose proposal boxes. Lastly, we can compute a proposal feature map for future detection and classification. Once we have the proposal feature map, first, just like in region proposal network, we use softmax layer to do the classification on specific region of interest. Output a class probability vector containing the probability of this proposal belongs to each object. Secondly, we use bounding box regression to find better box for the proposal. Lastly, we will have 2 outputs. One is the class probability vector and the other is the box coordination. Use those information, we can drop the box and highlight the object type.
So for the training process, we have used an open source implementation of faster RCNN to train the model. The total loss is a combination of classification loss and bounding box regression loss for regional proposal network and final classifying layer. So this is the total loss graph of the model that we trained on. The whole process takes approximately 18 hours. Reference list is at the end of the PPT.
So here is the result after we train the model and do the detection and classification. So we can see we can detect multiple objects and with high accuracy for one image. And this is another example. So we have chair, we have dining table and a person, and here we have bicycle and person and car. So we can see the other change the model with different networks such as ResNet 101 on the same dataset will result in a better accuracy. And we also can see when we use selective search for finding proposal needs more processing time and with lower accuracy. So during the project design, when we do the detect part, we cover the topic in lecture 18, and for the recognition part, we cover the topic from lecture 15, and for the convolutional network, we cover the topic from lecture 14. And for the project design, Zhao Hongmai did the part for training and write the code for region proposal network and detection, and I, Tingyu Yang, write the code for region of interest pooling and classification.